Good morning, students. So, our topic for today is slope deflection method, as I have written here. Slope deflection method. This method was developed by S.A. Mane. Okay. So, what he did is he proposed two equations. First one is, let's say, चलो ओके. सो इस मेथड में होता क्या है, देखो. इसमें जो मान लो कोई बीम है ए बी. ये कोई बीम है, ठीक है. और इसमें कोई दो लोड्स लग रहे हैं, W1 एंड W2. तो इस बीम ए बी के लिए ऐसे मैंने जो है उन्होंने एक इक्वेशन दी है, दैट इज MAB इक्वल्स टू MFAB प्लस 2EI अपॉन L, ब्रैकेट में 2 थीटा ए प्लस थीटा बी माइनस 3 डेल्टा अपॉन L. दूसरी इक्वेशन दी है MBA इक्वल्स टू MFBA प्लस 2EI अपॉन L, 2 थीटा बी प्लस थीटा ए माइनस 3 डेल्टा अपॉन L. तो इन्होंने ये दो इक्वेशंस इसके लिए प्रपोज की, दिस वन एंड दिस वन. तो इन्हीं दो इक्वेशंस को यूज़ करके हमने क्या करना है, आपने प्रॉब्लम्स को सॉल्व करना है. तो ये जो स्लोप डिफ्लेक्शन मेथड है, वी यूज दिस मेथड फॉर प्लॉटिंग shear force and bending moment diagrams for indeterminate structures. ठीक है. और इसमें कुछ इंपॉर्टेंट पॉइंट्स है, जैसे कि साइन कन्वेंशंस. तो साइन कन्वेंशंस कैसे लेने हैं. पहला साइन कन्वेंशन क्या है कि जो क्लॉकवाइज मोमेंट्स होंगे, ठीक है, क्लॉकवाइज, ये मैं बात कर रहा हूँ किसकी, एंड मोमेंट्स अगर क्लॉकवाइज होंगे तो दैट विल बी टेकन एज पॉजिटिव. and if they are anti-clockwise then it will be taken as negative. दूसरा y, ये सब चीज़ें कब होंगी, जब हम ये सब चीज़ें होंगी while writing slope deflection equation. And B, while drawing SFT, that is shear force diagram, and BMD, that is bending moment diagram. So while drawing shear force and bending moment diagram, we will take sagging bending moment as positive and hogging bending moment as negative. Other than this, we will take clockwise rotation as positive and anti-clockwise rotation as negative. ठीक. Okay, then for sinking of supports, if the left hand support, this is our left hand support, this is our right hand support, if this right hand support sinks downward like this by an amount delta, okay, then this delta will be taken as positive, okay. Which delta I am talking about? This one, okay. So if the right support sinks downwards with respect to left support, then it will be taken as positive. If the left support like this, left support sinks downward as compared to right support, then it will be taken as negative. Or I can also say, if the right support sinks upward direction like this, then it will also be taken as negative. Okay. So we can also say when the rotation will be clockwise. See here, this rotation is clockwise. This is one support, this is another support, and the movement is like this clockwise. And similarly here, one support, another support, and the rotation is anti-clockwise. There it was clockwise, and here it is anti-clockwise. Okay. Another important point which we need is the number of simultaneous equations required in slope deflection method to find okay. So let's solve a question. Analyze the continuous beam shown in figure if the support C sinks by 10 mm. E is given as 2 into 10 to the power 5 Newton per. I is given as 3.6 into 10 to the power 7 millimeter to the power 4, and use slope deflection method. Okay, and the beam is given like this. This is support A, again here it is support B, support C, and this is support D, and these distances are 4 meter, 4 meter, and 4 meter. Okay, so and this support sinks downward. This support sinks downward by an amount of 10 millimeter. So we need to draw shear force diagram and bending moment diagram for this continuous beam. So how will we do? Let's solve the problem. Solution. So first thing we will do is we will find out the degree of kinematic indeterminacy. We will find out degree of kinematic indeterminacy. Okay. So how we will do that? We will check all the possible rotations and displacements at all the joints. Okay, as we have done it earlier in previous semester. So at this support, since it is a fixed support, so there will be no rotation and no vertical and horizontal displacements. So here it will be 0. Here one rotation is possible, theta b. Here one rotation is possible, theta c, and here also it is 0. So dk will be equal to 2 theta b and theta c. And whenever we will analyze our problem with this method, we will always assume that the members are inextensible. Okay, there will be no axial deformation considered. So this is an assumption. Okay, so dk is 2. Okay, so we will need two simultaneous equations for this. Okay, so what equations do we have? We have MAB equals to MFAB plus 2EI upon L brackets 2 theta A plus theta B minus 3 delta upon L. So this is our equation 1. Similarly, we have MBA MFAB plus 2EI upon L 2 theta B plus theta A minus 3 delta upon L. So these two, we have these two equations, equation 1, equation 2. By using these two equations, we need to solve the problem. Okay, so what we will do, first we will find out MFAB for all three spans. This means we need to find out MFAB, MFBA, MFBC, MFCB, MFCD and MFDC. And what is MF? This MF is fixed end moments. Okay, so let's find out MFAB. So we will consider the span